Hello friends, welcome to this next video on classical mechanics. In the last video, we have seen that we have derived the law of conservation of energy for the system of particles. So now we have three laws, that is law of conservation of linear momentum, angular momentum and energy for a system of particles and for a single particle. Right now we are still we are dealing with the system of particles, and we would like to know how can we write the kinetic energy of a system of particles in terms of the position vector of the center of mass. Kinetic energy of a system of particles. We have seen that we have written the linear momentum of a system particle, and we have written the angular momentum of a system of particles in terms of the position vector of the center of mass. So we would like to write the kinetic energy of a system of particles in terms of position vector of center of mass. Okay, let us do that. It is very simple. So you just what is the picture? We have these n particles, right? These are your n particles, first particle, second particle, and so on. This is your ith particle, and then somewhere you have your center of mass. Okay, so suppose this is the position vector of the ith particle, I'll call it Ri, and then you have your position vector of the center of mass, we will call it as capital R, right? And then we will draw this position vector of the ith particle with respect to the center of mass. This is your origin, so this Ri and capital R, these are the position vectors with respect to the origin. And suppose this is your Ri dash vector, right? So that is the position vector with respect to the center of mass. That position vector is of the ith particle, right? From here, from the law of vector addition, triangular law of vector addition, you can see that your Ri vector is nothing but capital R vector plus Ri dash vector. So that is this vector plus this vector is equal to this vector. This is from the triangular law of vector addition. So you have this thing. Now if I differentiate it with respect to time, so I'll get dri by dt vector is equal to dr by dt plus dri dash by dt. So what is this? This is the velocity of the ith particle with respect to the origin, that is vi. So this is the velocity of the center of the mass with respect to the origin, and this is the velocity of the ith particle with respect to the center of mass, right? So I have this relation and I have this relation, right? I'll use these two relations to derive what I need. I need to write the kinetic energy of a system of particles in terms of the position vector of the center of the mass. So what is the kinetic energy? We already have the expression. This is half mi vi square. Okay, I. So idea is you take the kinetic energy of the ith particle and then sum over all the particles, then you will get the total kinetic energy of the system. So how can I write this? This is equal to summation half mi vi square is nothing but vi dot with phi vector, right? Now I'll use this relation. So I'll get this is equal to summation half mi. I can write vi is my v vector plus vi dash vector dot product with v vector plus vi dash vector. Okay, right? Now we can use the distributive law here. So this you have half mi. What you will get? You will get v dot v plus v dot vi dash plus vi dash dot v vector plus vi dash dot with vi dash vector, right? So this is summation over I. So you have summation over I half mi. This is your v square. Okay, v is the velocity of the center of mass with respect to the origin, and these two terms are same, so you'll get, and half and twice will cancel, so you have this v dot with vi dash, okay, with mi, okay, plus this is your mi vi dash square, right? So what you have the first term and the last term. This is the half factor is here, so you have first term is I, half is outside, summation is over mi because v is independent of I, so I write it as v square, plus you have the second term, I'll write down later, and then you have the last term half summation mi vi dash square, plus you have this second term. I can write the second term as vi, okay, v dot, this is your summation over I mi vi dash. Okay, so what do we have? Let us see. Okay, so you have this first term is, what is this? Your capital M, that is total mass of the system. So first term is half capital M V square, plus the second term is half summation Mi Vi dash square. I'll prove that last term is 0. I'll just prove it. If I can prove that this term is 0, then this is the kinetic energy of the system, right? Now you can see what is the kinetic energy of the system. The kinetic energy of the system is equal to, what is this? This is the kinetic energy as if the whole mass of the system is concentrated as at the position vector of the center of the mass, right? So this is the kinetic energy of the system of the center of mass. I'll write down like this. Okay, so what is this? This actually, this term denotes the kinetic energy if whole of the mass of the system is concentrated at the center of the mass. And what is this? This is the kinetic energy of the system with respect to the center of mass. This is the kinetic, because this is Vi dash, and Vi dash stands for the velocity of the ith particle with respect to the center of mass. So this is the kinetic energy of the system with respect to center of mass. Okay, so you can see that the kinetic energy, total kinetic energy of the system is equal to kinetic energy of the center of the mass plus kinetic energy of the system with respect to the center of mass. Now we are left to prove that this last term is 0. This is pretty simple. We have already done these things, that the last term is 0. Let us do this again. How can we prove that this last term is 0? You have this term summation Mi Vi dash, so I can write it as dy by dt of summation Mi Ri dash. Okay, now this is 0. How? Because we have this thing, r vector plus Ri dash vector is equal to r vector, right? So my, this is equal to, sorry, this is Ri vector. So this thing is equal to this thing, this quantity is equal to summation Mi Ri dash. I can write it as r vector minus, sorry, Ri vector minus r vector. From this relation your Ri dash vector is Ri vector minus r vector. So this is equal to summation Mi Ri minus, this is summation Mi, and r is independent of I, so I'll write it outside. Okay, now what is this? This is, I can write it as summation Mi Ri divided by summation Mi, and I can multiply with summation Mi minus, what is this? This is capital M, that is total mass of the system, into r. So now what is this? This is by definition the position vector of the center of mass, that is r vector. So, and this is capital M summation, that is total mass of the system, mr minus mr. So this is equal to 0 vector, right? So I have this term as 0 vector. This is your 0 and 0 vector. So derivative of 0 vector is 0 vector. So this term is 0. Okay, so that is how this last term is 0. So in this video we have proved that the total kinetic energy of the system, total kinetic energy of the system is equal to kinetic energy of the center of the mass plus kinetic energy of the system with respect to the center of mass. Thank you.